Question number 24 from paper 1 HR, January 2022. It's a vector question. OXYZ is a trapezium, and the position vector for OX is given, which is A. So OX is here. So this is A. XY is B. This is B. And O2Z is 3B. Okay. So M is the midpoint of OX. As M is the midpoint, so it means that this length is divided into half. So OM would be 1/2A, and MX would be the same, 1/2A. N is the point such that M and Z and O and Y are straight lines. Okay, so these are straight lines. It means that they're parallel lines. They're equal. So given that N ratio OY is lambda ratio 1, so the full length is 1, so this full length is 1, and ON has a ratio lambda. Okay, so let's start. Because I have to find out lambda, the fraction of this length, so I will take here two roots. So let's write down root 1, 2 roots of ON. So root 1 for ON. So let's write down root here. So ON is having some ratio of the total length. So I can write down, let's say this lambda is a fraction of the length, and I can write down lambda of the total length, which is OY. What is OY? Let's find out OY here. So OY is basically O to X and X to Y. So this is OY. So O to X is A. Write lambda as it is. OY is basically OX plus XY. So OX is A plus XY is B. So the complete root of OY is A plus B, lambda. Let me rewrite lambda. Okay, this is root 1. Similarly, I will find out root 2. So once we'll get two roots, I can equate them. So root 2, same thing, ON. Let's take another root for ON. Okay, let me erase this line here and here. Okay, let's take another root for ON. So that could be OM plus MN. So OM is A, half of A. This is half of A. And MN, I don't know, so definitely it's a fraction of the total length, and the total length here is MZ. So I assume that ON is lambda, so I can assume MN is nu. So ON is equals to OM plus MN, and OM is half of A. And MN, I assume that nu of the total length, which is MZ. So you can use any letter, okay, because they have given lambda here, so I just use nu. You can use X or Y as well, so that doesn't make any difference. So the total length is MZ. Okay, let's continue. Half of A plus nu. Now let's find out what is MZ. So before that, let's look at the root of MZ. So MZ is, we will follow this root, MO plus OZ. MO is opposite direction, so this would be negative. OZ is 3b. Okay, so this is my second root. Now it's time to equate root 1 and root 2. This one is the first root and this one is the second root. Let's equate 1 and 2. So the first one is lambda a plus b equals to, the second root is half of a plus nu minus 1 over 2a plus 3b. It's time to expand bracket. So lambda a plus lambda b equals 1 over 2a minus 1 over 2a nu plus 3b nu. Now equate a and b. Equate a and b. So I get lambda. Equate a and b. Alright. So let's equate a and b. A is lambda a and 1 over 2a minus 1 over 2a nu. Okay, let's equate a first. If I equate a, lambda a equals to 1 over 2a minus 1 over 2a nu. A is present in all terms, so it will get cancelled. So I can take out common, I can factorize it, and now this is cancelled out. So lambda equals to 1 over 2 minus 1 over 2 nu. Okay, now let's equate b. To equate b, what do I have? Let me highlight it. Lambda b plus 3b nu. Here it's equal. Okay, b cancelled and lambda equals to 3 nu. So value of lambda is 3 nu. So if I find out nu, I can divide by 3. So let's use this value of nu in here because I need to find out what is lambda. So lambda equals to 1 over 2 minus 1 over 2 into 1 over 3 lambda. And let's simplify it. Half into 1/3 is 1 over 6 lambda. So move this one here to solve equation. Lambda plus 1 over 6 lambda equals to 1 over 2. Lambda plus 1 over 6 is 7 over 6 equals to 1 over 2. Now find out what is lambda. So 1 over 2 into 6 over 7, and lambda equals to, I can cancel out, and this has cancelled by 2. So 3 into 1 is 3 and 7. 3 over 7. So lambda is 3 over 7. Okay, use a vector method to find the value of lambda. So we got this is 3 over 7. So lambda, it means this length is 3 of 7. This is question number 24 from paper 1 HR January 2022. If you want to watch more videos on vectors, go to the playlist. You will find plenty of questions on vectors. And if you like the video, don't forget to like and subscribe. Thank you very much.